Okay, friends, it is time, and we got to roll. So, investigating side lengths of right triangles. Can we do triangles that are not right angled? Yes, eventually, and by eventually I mean later next week. Like coming right up. So you can just be patient, we'll get to that. So today we will see the beginning. So not everything has to be clear after this investigation. That's what I want to warn you about. It doesn't have to be like, I totally get it. It'd be like, whoa, that's all you're trying to get out of this right now. We will see the beginning of how to solve for sides in triangles the right way. Thank you, thank you, thank you. So for each triangle, you now have the weapons you need. Measure the You can have time in just a second, just listen. Measure the indicated angle, where the smiley face is, using your protractor. Record the angle value in the triangle. Your teacher, whoa, I got responsibilities here, will help you label the opposite and adjacent sides, and you can be like, I don't know what you mean by opposite and adjacent. I mean, I know what opposite means. I've never seen the word adjacent before. No problem. That's my job. Before you start the investigation, I got to explain what that means. Use your ruler to measure each side in centimeters to 1 decimal place, which is probably all you can do with a ruler is 1 decimal place. And then use your calculator to do the calculation for the ratio of opposite over adjacent. Do that to 4 decimal places. You'll need your calculator for that. What are you talking about? Here, I'll do one with you. Okay? Get out your protractor and measure the smiley face angle. Someone's already yelled out, spoiling it for the rest of you, that it's 30 degrees. How to use a protractor? Good. Put the little right angled part right on the vertex of the triangle. Let me just lock down my background here. Okay, write down the angle right on your triangle there. I also got 30 degrees. Now really listen for a second, will you please? Because this is a detail you need to know. Shh. This is the 30-degree triangle. Yes? That's the 30-degree angle over there. That's the angle I'm going to use in this question. I know there's going to be lots of questions after I do this, but just leave them on the shelf for now. This side, this diagonal side over here, we already know what that one's called. It's already got a name. You can label it or not. I know that part's in the lesson. It seems like I'm ignoring that side. I'm not. I'm just leaving it out for just a second. I need to tell you about the other 2 sides. From the 30-degree triangle, the side that's over on the opposite side of the triangle is called the opposite. And we're going to use it so much that soon you'll see a short form OPP for opposite, okay? Next, this other word, adjacent. Have you seen the word adjacent before? Adjacent means beside, yes? And it's beside the angle, but not this one beside the angle, because that's already, we already know it. What is the name of this other one? We already have a name. It's the hypotenuse. Okay, so we're just naming the other 2 sides. And maybe you never saw that before, that those 2 sides have names. Now you're off to the races, okay? What I want you to do is measure opposite with your ruler, measure adjacent with your ruler, and then get your calculator to divide and do it for all, is there 5? 5 triangles? All different triangles. And we'll take it up in a few minutes. If you're not sure how to measure, I'm going to do it on my screen as well. And you're like, what? You'll get completely different measurements. I'm like, I know. That's what's so cool about the investigation. If you too, you can just do it right on your screen. Peter's like, I'm going to have different size triangles. Yeah, I know. It's good. Well, let's see if I actually have a ruler on the screen. So for those of you watching a video, you can actually see me do this. It'll get loud in the background as they're doing their work there. Oh, I do have a ruler. Look at this. There we go. I get 76 somethings. I'm going to call it 7.6. Okay, so, oh, that's adjacent. Adjacent 7.6. And now, I got to twist and do the opposite. You can hear the noise in the background. They're all busy working, but this is just for video's sake. Okay, so this ruler's a little awkward on the screen to get it all lined up, but it works okay. And so here I see 4.4. Maybe you think it's 4.3, but for the opposite side, I get 4.4. Oops. And then I'm going to get out my calculator, and I'm going to divide those two things. Folks, we don't have forever. You can be chatty, but get the job done, please. Oh, there's my calculator. There we go. And all I'm going to do, oh, I got two of them. So it said do it to 4 decimal places, so I did 5, 7, 8, 9. Okay, that's all. Now I'm going to let them work, and I won't do the rest of them, but we'll take them up together. So if you're doing this at home, just go and do those opposites divided by adjacents for all the triangles, and in a second you'll get to hear me take it up with my friends here in class, who suddenly have talked less and they're getting to work. It's very exciting. I guess we're done with this, are we? We've had enough of this? What's that? What's this one called? Hypotenuse. Yeah? Oh, you're jumping ahead. Yeah. Yeah. It's weird that we never had names for the other sides before. Please try to finish up the next couple minutes, because the whole lesson's still to come. While you're doing that, I'm going to hand out the chapter notes. The last chapter notes of the course. Aren't you excited?
No, I'm awesome. Wait, is this supposed to be the opposite 3.4, is it not?
You might not get the same as me, because I'm using a big ruler on the screen, which might freak you out. And Peter's doing it on an iPad, and you're like, wait a minute, he might not get the same as us. And I'm telling you, that's what's going to be amazing about the whole thing.
Oh, because the ratio of the side lengths.
It'll be different.
Yeah, the side lengths might be different. Okay, we're getting ahead of ourselves, but maybe you're already seeing through it. You're like, oh. When you're done, do me a favor, and all your results, take them and just quickly average them. We'll need that in a minute anyway, so just take your 5 triangles and average them. And while they're doing that, I'll do a few more on my screen. This is like grade 4, someone says. That's good.
I read 0.67. 5. 0.7.
My numbers were like 0.5.
All right. Did you have enough time to get through this? You're good. Okay, so this is the part that could freak you out a little bit. I'm doing the measurements up here and getting completely different side lengths. Peter's doing it on his iPad. Depending on how much he's zoomed in, he's getting completely different side lengths, and I don't care. That doesn't bother me at all, because some of you might already be seeing what's happening. When I measured on my screen, my big ruler said 4.4 over 7.6, and I got 0.5789. For the next one, I got 3 and 5.2. And so when I put that in my calculator, I get 0.5769. I'm already suspicious. Does this happen in math investigations all the time? You do a bunch of stuff like, yeah, they're all the same. I'm not sure what's happening, but they're all the same. Here, let me do another one. 6.8. No, they're not exactly the same. You're right. We'll talk about why they're not exactly the same in a second. 5812 I got. And then I got 0.5755. And then 2 divided by 3.4. 0.5882. I must be honest, I did mine on the screen pretty fast. Did you measure all the angles? They're all 30s. Okay, they're all 30s. What kind of numbers did you get?
30 and 60.
0.5. What decimal place? Here, let's average them. Everyone take a second and average your 5 numbers. So add up your numbers and divide by 5. So I'm 5789, just the decimal part at the end. 0.5769. Shh. No, just the opposite over adjacent. Add those up. 0.5812 plus 5755. And 0.5882. And when I divide by 5, I get 0.58014. Yeah? And that was measuring pretty quickly. Did anyone get up to 5.8? Yeah, everyone down into 0.57s somewhere? Yeah, so 5.7, 5.8, somewhere in there. Now, why are we all getting different answers? There's 2 main problems with what we just did as far as accuracy is concerned. Yeah, you might have been partway between 2 of them, so you made a decision to go up or go down. Maybe you made a mistake. Maybe you looked at it and like, oh, you didn't have it right lined up, your finger moved a little bit. And in the end, the ruler isn't that accurate a measuring device. Okay? So there's a little bit of error here. So if you're off a little bit, 0.57, I think one of my ones was really off, wasn't it? It was like 0.6. I did one of them really fast. 5812. 5.769. Mine were fairly consistent. Maybe because I'm measuring on the screen, I was able to be more consistent. But if you had one that was like 0.6, okay, 0.54, fine. here we're ready to do our consolidation. And then I'm looking for someone to be sort of clever about what's going on here. It appears that opposite over adjacent in a 30-degree right triangle is about, and when you guys raised your hands, it seemed like there was more 0.57s than there was 0.58s. But again, I'm not trying to rig the results. I'm just trying to say that's what I saw. You got 5.5, so that would even bring us down anymore. If we average all our results, it looks like more like we're getting about 0.57. Yeah? Now, reach down under your chair, grab the seat belt, and do it up just in case you pass out when I show you this. Take out your calculator. Take out your calculator. Make sure it's in degree mode. Here's how you'll know if it's in degree mode. You look up at the top, and it'll say, mine says DEG at the top. Most newer calculators just have the letter D at the top. If you don't have a D at the top, well, different calculators are different. Mine has a DRG button, and so I can switch it from degrees to rad. Ooh, rad mode. Yeah? I can switch it to grad. It's actually called gradients, and the other one's called radians. And you learn about those in other grades, but make sure you're in degree mode. If you're not in degree mode, hit setup and then degrees. Is anyone not in degree mode? All right. Oh, not in degree mode? Here, let me get you in degree mode for you, because I don't want you to miss this big moment. It's shift, setup, and then 3 for degrees, and now it says degrees. Anyone not got D or degrees at the top? Mode. Oh, this one you got to hit mode, mode. You got to hit mode twice, and then you get degrees on the screen. Degrees, yeah. It'll say D or DEG. Get ready. Whoa. Got your seatbelts on? Hit on your calculator a button called, well, okay, hang on. Before you do it, get some lotion on. Okay? Hit the tan button. Then, what was the angle we did? 30. Hit tan 30. Don't press equals till you're ready. Now press equals. Oh, fancy calculators give it with a fraction. Then hit change to get it to a decimal. The calculator knew before we even started. How does the calculator know? Well, here's what somebody did. Actually, this is not true what I'm going to say. But here's what the calculator does. It draws 400 triangles of 30 degrees. It takes all the answers like we did and averages them, and here's what it got. It doesn't do that. It's got a better way to do this calculation. But that's the way you can imagine it if you want. Somebody went through and took thousands of people with thousands of triangles, averaged them all, and they decided if we're very accurate, this is what we get. And we did pretty well. Because I was saying 5.8, right? It really is close to 5.8. There's a lot of you are 0.57. If you're off a little bit like that, well, maybe you just need to be a little more careful with your measuring. But that's not what we're going to do. We're almost done with the rulers and the protractor for the whole chapter. We're not going to do that anymore because we got this weapon, whatever it is. One more sentence. If you press tan 30 degrees in your calculator, you get about 0.57. And I hope you understand that all those other decimal places are just because the calculator is really good at whatever we're trying to do here. It's got a better ruler than us. And again, for you future computer programmers, the calculator knows even more about this situation than what we're talking about. But what I've said is a good way to visualize what's happening in the calculator. Yes? Now, after that 0.57, though, I want to know, chapter's not over. So I'll put an exclamation mark like, whoa, that was amazing. But then I'll put a question mark going, but I have 1,000 questions about how this is going to be used and how we're going to play it. Like, yeah. Like, I don't just have 1,000 questions. I'm not even sure what just happened. But I am amazed. So this can have, this consolidation's like, Like, what are we, 11 minutes into the chapter, right? What special side did we not label? Hypotenuse. And I'm not trying to leave it out. We will get hypotenuse right back in here very soon. How do we identify this special side? How did you know? When you look at a triangle, how do you know which one's the hypotenuse? The long one. And there's another way to know. Half of you might have thought of something else. It's the longest side, but what else is it? It's opposite the right angle. So it's special. It really is a special side. The other two we're going to have to be careful with a little bit. Okay? Investigation over. That's just supposed to be motivating. I'm going to use a lot of what we saw there to establish stuff. And then we switch over to the note, which we typed up for you because I don't want you writing all this stuff down. It's a lot of details. So I'm going to go through them fairly quickly. A lot of details. Some of it I already showed you. Some of it brand new. I'll try and move fairly quickly. Yes, we do get paid over the summer, but not how you think. The salary for the year of a teacher is decided, whatever that's going to be. Then they take that, and again, we don't get money for the summer. You get paid for how many weeks you're going to work, which is somewhere in the neighborhood of 39 weeks. So that pay is for 39 weeks. But they nicely take it and divide it into 26 pays so that teachers don't run out of money in the summer. So the money I get in the summer is money I already earned. Yeah. So when they say teachers get 13 weeks vacation, that's yes, we do. We get 13 weeks off, but we only get paid for 39 weeks. But they make it, they make it worth it in Ontario, for sure they do. Yeah. Other jurisdictions, like you go to the States, teachers don't make, as much as we do. Canada does very well. Yeah. Okay. Okay. Pretty quickly here, pretty quickly. But you stop me, because I think I covered some of these things, and some of them might be like, oh, okay, I get that. The primary trigonometric ratios, whatever that is. Well, actually, maybe ratio, you're like, okay, we did a ratio today. We did opposite over adjacent, and I'm going to explain how they're called trigonometric. Determine the values of sine, cosine, and tangent. Ooh, that's what we did. Tan. We did tan. But tan's only a shortcut. It's a shortcut for the word tangent. Does that mean something in all this? Yes, but for now it can just be this mysterious word tan. That's okay. For a specific acute angle in a right triangle. So what we're going to be studying is trigonometry. You've already done some trigonometry. We're adding on to your trigonometry. Maybe it wasn't called that, but you've already done some trigonometry. Last chapter we were doing trigonometry. It's the branch of mathematics that deals with properties of triangles and calculations based on these properties. Can it only be used in triangles? No, we can expand, but for now we'll talk about triangles. Opposite and adjacent, I already talked about this. These are relative terms. What do I mean by that? Well, look at the clock. What side of the room is the clock on? The right side. The right side. I say it's on the left side. That's going to happen with opposite and adjacent. It depends on how you look at it. So in any particular question, yeah. Okay, hey, stop that. Shh. So here we have, D, A, B, C. Did yours do D? Yeah, it did. Something happened with the fonts there. That was supposed to be triangle. So if you could just write over top of your D there, triangle ABC. Let's say our perspective is angle B. Then AC would be the opposite. See, if we're going to use this angle, this side becomes opposite, and I'm already over writing the whole word opposite. We'll use OPP for opposite, and this will be adjacent. If you decided to use the other angle, you'd have to reverse those, just like the clock. Yeah? You think it's right, I think it's left. If you look at it the other way, these things are going to reverse. Now, the idea of opposite and adjacent for any geometric object is simple. The sides that form an angle are adjacent to that angle. So here in the picture, adjacent is these two sides right there. They're both adjacent to the angle. They're attached to it. They're beside it. In this picture, A and F are adjacent, as they are marked on the sides that join the angle. B, C, D, and E are opposite. They're out there away from the angle. Is that okay? Yeah. That's just the details of what I already showed at the start. But in a nice note form so you can look at it. The problem with the word adjacent is that there will always be two sides that are adjacent to any particular angle. For instance, if I use this angle here, you might go, but BC and also AB are adjacent. But no, that's not how it's going to work out. Because what's AB? Before this question even starts, we gave it another name. The side AB, what's that thing called? That's called the hypotenuse. And again, there's the shortcut. Because we're going to write this on so many triangles, we'll write just HYP. In fact, some people just drop all the way to H. But I encourage you to stick with HYP for a while. So it's not going to be a problem. In any triangle, we'll be able to label the hypotenuse, label the opposite, label the adjacent, and there won't be confusion once you get it practiced. Are there any questions about that? Again, that's a lot of paragraphs to explain something you could have just said at the start. You got an opposite and adjacent side, the long one's the hypotenuse. So let's see how the labels works. Here's two nice pictures for you to look at when you get confused about opposite and adjacent hypotenuse. If I use this angle, AC becomes the opposite and BC is the adjacent. If I use this angle, BC is the opposite and AC is the adjacent. That does bother some people. I'll go back to my clock example. It's just the way it works out. To you, the clock's on the right. To me, it's on the left. So based on what angle you use, you're going to have to change these around. It says what I just said. The sentences say what but when you're confused, you can look back at these notes. But many people, by this point in the note, are like, I got it. I got it. Yeah, thank you. So, looking at this triangle using B as our perspective. So, for the rest of this page, I'm going to use B as the perspective. And if you get confused by these things, I encourage you to circle them. So you're like, there, I got it. I know which angle I'm using in this question. There are three ratios we use. We saw one of them already. Yes? We already saw what opposite over adjacent looks like. But you could do other things. You could do opposite over hypotenuse, or you could do adjacent over hypotenuse. Yes, you could flip all these and do them the other way around. We're not going to do that. These are the three we'll use, and you'll see why these are so good as we come up. Each of these ratios has a name. We don't want to go around writing opposite over adjacent all the time. So there's a shortcut for that you've already seen. And it says tangent. In fact, we even shorten that down and call that tan. But that's short for tangent. Why is it called tangent? Ooh, coming up. Well, I'll be able to explain in other grades why it's called tangent. For now, it's just the name we use. And this one's called cos. And this one's called sine. Not sin. Especially not here at Catholic school. Geez, come on. Sine. Because it's a short form. I know it's spelled sin, but that's the shortcut. The short form. How am I going to remember all this? Well, anybody after grade 10 math has seen this before. SOHCAHTOA. In fact, if you go home, it wouldn't surprise me. Any one of your parents, if you said, hey, I learned about SOHCAHTOA today, they'll go, yeah, I remember SOHCAHTOA. Some people get mad to me and say I should be pronouncing it SOHCAHTOA. SOHCAHTOA, not SOHCAHTOA. I don't know why I say saw, but I've got it memorized, so what do I care? Yeah? But for you, it might be SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. It's just a handy acronym to remember this. Now, before you get upset and say, I'm not going to memorize it, wait till you see. We're going to practice it so much, you might memorize it by accident. Some temporary tattoos, that's what we need. SOHCAHTOA right on our arm, yeah? It's a great idea. On this side, SOHCAHTOA, this side quadratic formula, and you're ready to go out into the world, yes? Okay, now's where the lesson actually begins. Here's where we go, do you know what's happening? It says, find the three primary trig ratios for angle A. One step at a time the first time you go through it. It says do angle A. I encourage you to circle angle A and go, that's the one I'm going to do in this question. Then label the sides. If this is confusing at all, go after hypotenuse first. You know which one that is. That's the long side. That's the one across from the right angle. That's hypotenuse. All I have left is opposite and adjacent. Which one has to be the opposite? I find this one the easiest one. What's that? The 8 centimeters has to be opposite because it's over on the other side, and that means this one's adjacent. Hopefully at this point in the lesson, you're like, okay, I think I can do that. Okay? The other part you're going to have to look back at. Until you get this memorized, you're going to have to look back at. It says find sine theta. Actually, that's not what it said. It said find the three primary trig ratios, which are sine, cos, and tan. Right in your calculator, you can see them. Sine, cos, tan. Now, sine is opposite over hypotenuse. So you'd write, okay, that's opposite. I don't know why I wrote theta. I've been teaching too much grade 12s. Yes? Sine A is opposite of hypotenuse. And so that's 8 over 14.42. Should I leave it as a fraction? Should I get it as a decimal? Relax about that for now. We'll get to all that. For now, I just want to get it so you can write it on the screen. What's the next one? Cos, short for cosine. Take a look back and start doing the memorization by repetition. What's the ratio cosine? Adjacent over hypotenuse. Go ahead and use the short forms. Adjacent over hypotenuse. And so that's 12 over 14.42. And then our old friend tan, which we've already learned about, and maybe you already have it memorized because of the investigation. That's what I'm talking about. If you use these enough, you might just memorize them by accident. And I get opposite over adjacent, which is 8 over 12. That's not all there is to the story, friends, but this is on our way to everything. This is really a two-part lesson. You got to put today's together with Monday's before the whole picture becomes clear. So in this question, circle the angle. Which one's the hypotenuse in this one? I've tried to mess you up by rotating it all around. This 10.3. Then which one's the opposite in the picture? 9. Leaving the one beside here have to be adjacent. Hopefully that calms you down and goes, oh yeah, there won't be any ambiguity here. I'll be able to label these every time. So then sine of A, opposite over hypotenuse. And I've gone to the very short shortcut there. But do you see the problem with the very short shortcut? That looks like a 0 or an O. That can mess you up unless you really know what you're doing. So be careful with that kind of shortcut. And so it's just 9 over 10.3. I like it. I like it. And that's adjacent over hypotenuse. And now there's the letter A, but A's in cos A. Oh, now I'm confused. Okay, don't use that as your shortcut. Use ADJ if it confused you at all. And so I get 5 over 10.3. And then tan, our old friend tan, is opposite over adjacent, which is 9 over 5. I promise this is going somewhere. This isn't just listing numbers. There's something we're going to be able to do with this very, very soon. Like Monday. Monday we'll be able to do some stuff. This lesson, a lot of labeling, okay? Do you have any questions there? Please ask me. I know we're rushing just a little bit because of the fire drill, but I do want to stop and say, what is any of that unclear? The investigation does a good job of going to get you the gist of this, yeah? Okay, find the three primary trig ratios for the indicated angle. What indicated angle? Oh, it tells you. Sine A, cos A, tan A, cos B, sine B, tan B. Okay, whoever typed this up was like, okay, let's make sure you know what you're doing here. I suggest do all the A's first. Circle A and use that to label the sides. Opposite, adjacent, hypotenuse. And once you're good at that, this goes really fast. Yes? Sine of A, what's sine of A? Opposite over hypotenuse, so that's 5 over 13. Cos of A, what's cos of A? Adjacent over hypotenuse. It'll happen for you. Trust me. Memorization of these really is not most people's problems. And because I'm doing A, I'll finish off with tan of A, even though these are wrote sort of all over the place on me here. Tan of A, opposite or adjacent, which is 5 over 12. Now here's the challenging part, friends. When I want to go to do B, I got to go back and relabel the triangle. Yeah? I got to go back and go, no, I'm doing B now. So if I'm doing B, and I'll do it in another color here. If I'm doing B, then this isn't adjacent, this is opposite, and this isn't opposite, this is adjacent. Hypotenuse gets to say the same name. It's always the hypotenuse no matter what. Well, now everything changes. Cos of B would be 5 over 13, which is the same as sine of A. Dun, dun, dun. Yeah? While that's important and true, we won't do much of worrying about that, actually. That's not what we'll be working on, but that comes up later, yes? Tan of B is opposite over adjacent, which is 12 over 5, which is tan of A flipped. That's neat, but not something we're really working on, actually. So this isn't the investigation part. And then sine of B would be opposite of hypotenuse, which is 12 over 13, which was the same as cos of A. Now, we don't really have to investigate that, but I'll just mention it. If you switch angles, you switch the names of the sides, so you switch from sine to cos because sine and cos are just changing the roles of opposite and adjacent. That's not what we're working on, but I just mentioned that's completely true. You got some questions? I think that's basically what tonight's homework gets you to do. It's just label sides and come up with the ratios in preparation for Monday. Round to 4 decimal places as necessary. Well, okay, you could then type those in your calculator. I'm going to leave them as fractions, not because I'm not doing a fraction speech. I'm just trying to make them fit in there. If you need them as decimals, we'll talk about when we might want them in decimals on Monday, because we will. We'll want them in decimals. You decimal people are going to be so happy because we're just going to use decimals all the time. Oh, here's another one. And then we're done. Okay, so we got time. Let's not wait till tonight to find out what you can do. Take 5 minutes and really try and walk through this one. Do either N or P first, because you got to relabel it to do it the other way, and see if you can do this for N and P, because then I just got to talk about the homework, because you might have noticed your package doesn't have a homework page list. It just didn't get finished, sorry. But it's okay, we're going to list, you're going to, yeah. Yeah, but you know that the other chapters had a nice title page where it was all listed there? Now you're going to have to look, this chapter you're going to have to look at the individual pages, which you're like, oh, well, that's okay. You don't have to spoon feed us that much. We can look at the page. Thank you, Mr. Todd. That's all right. We'll be all right. Oh. Do we have time? Yeah, we got 10 whole minutes on the clock here. Actually, what I'll do while you're working on that, if you can slide your protractor back into its protective sheath, I'll come and get that, and then I'll come and get rulers. And you just keep doing SOHCAHTOA on angle P and then on angle N. Oh, she refused, didn't she? She was too good for my protractor. I'm coming to collect my protractors. Thank you. Thank you. Thank you. Thank you. You're so good. Oh, he broke it. You bought it. 18 cents, please. I ordered these Wednesday at 10 p.m. And they're at my house Thursday at 3 p.m. You guys aren't impressed by that, but that. When I was a kid, everything was 4 to 6 weeks. If you ordered something, you had to wait. Did you steal the protractors? You already gave them to me, did you? I'm watching you. Suspicious.
Thank you, sir.
No, thank you.
Gracias.
Oh, yeah, you got one.
Thank you.
Now I'm coming for rulers, which I'm less worried about. Are you almost done? We got to take this up. We only have 3 minutes, then we got to take it up. Ruler? Yes. Ruler. Actually, these rulers I ordered from somewhere else. I ordered them from Egypt.
Wow. Egyptian rulers.
Yes.
That is
They're the rulers of Egypt.
rulers of Egypt. Oh my God. That took me a quick second.
That's a good one, isn't
That
it?
took me a quick second.
I worked hard on that one.
I was
The rulers of Egypt. Had that one in the holster for a while. What I like is that this is the first time I've taught you guys. Some of my other classes, I've taught them multiple times. So when they hear jokes that they've heard before, they are annoyed. They're like, yeah, rulers of Egypt, thanks. Are you almost ready? Was that enough time? Who needs more time? You're important. I'm going to do it freestyle, friends. Not to show off and not to rush, because somehow, some way, I actually have 7 minutes, even with a fire drill. I want to show off that with a little practice, this goes much quicker than we're talking about. I can look right at this. I don't need SOHCAHTOA. I don't need to label the sides. Yes? You should. You should label the sides. I'm just trying to motivate you that this will go well. This will go quick, and that grade 11s and 12s do these calculations very quickly. Because they just look and go, oh, sine P, opposite over hypotenuse, and they just pick it off. Because they know SOHCAHTOA so well, they can just go bang. It's SOHCAHTOA. Thank you. SOHCAHTOA. Cos of n, I don't need to redraw everything. Maybe it's easier if I just don't. If I just put my finger on n and go adjacent over hypotenuse. 9 over 15. Ooh, they're the same. Maybe you're not impressed. You're like, if you switch angles, opposite adjacent switch, so sine and cosine switch. And that's not even really part of grade 10 math, but it's interesting. What did you get for tan n? 12 over 9. Great job. If you got 12 over 9, you're like, I'm all over this. I am a trig machine. I dig trig. Oh, that's what we should do. New Spirit Wear shirts. I dig trig. I like this. I like this. I dig trig. Sine n. What'd you get? 12 over 15. If you got that, and don't please again one more time. Don't try and do it the short way like I just did, until you like totally got it. Label it. Do all that. Absolutely. I'm just trying to say this doesn't have to take forever once you're good at it. Cos P, I just point at P. That's how I do it. And I go adjacent hypotenuse, 12 over 15, that fast. And then tan P, 9 over 12. And yes, I see they're flipped versions of each other, but that's not really what I'm teaching. You can think of that as AP stuff, like I noticed that they just flip over. Okay, good for you. That's not what we're really doing, okay? All right, now, friends, you knew some trigonometry before you came in here. You knew Pythagorean theorem, so in your homework, it's time to go back and make sure I got it down pat. Practice that real quick. You got some labeling to do, which is just what I said here, and then try these, a few extra labeling ones, okay? If you're that good by the time you get to these ones, you want to do the shortcuts, I'm all for it. But if you're making mistakes, then you're not good enough at it. You should be labeling carefully. Yes?